A blockchain is a database that is shared across a network of computers. Once a record has been added to the chain, it is very difficult to change. To ensure all the copies of the database are the same, the network makes constant checks. Blockchains have been used to underpin cybercurrencies like Bitcoin, but many other possible uses are emerging. Here's how a deal gets included in a blockchain. Step 1. A trade is recorded. For example, let's say Mr. James is selling 2 of his coins to Mr. Michael for $100. The record lists the details, including a digital signature from each party. Step 2. The record is checked by the network. The computers in the networks, called nodes, check the details of the trade to make sure it is valid. Step 3. The records that the network accepted are added to a block. Each block contains a unique code called a hash. It also contains the hash of the previous block in the chain. Step 4. The block is added to the blockchain. The hash codes connect the blocks together in a specific order. A hash code is created by a math function that takes digital information and generates a string of letters and numbers from it. Don't forget to like, share, and subscribe to the channel. And if you like those videos, please ring that bell. Let's take a closer look at 2 important characteristics of hash codes. First, no matter what the size of the original file, a hash function will always generate a code of the same length. For example, the first tweet from Michael was much shorter than the one that is shared by John, but they would yield hashes of the same length. Second, any change to the original input will generate a new hash. So if someone decided to delete just 1 comma from John's 8,500 words, it would show up because the hash would change. The next block in the chain still has the old hash, so to restore the chain, a hacker would have to recalculate that, and the next, and so on. Recalculating all those hashes would take an enormous amount of computing power. The computers in a network, unlike traditional ledgers, a blockchain database is decentralized and it has no master. Here's our attempt to explain the original intent of the blockchain in fewer than 100 words. You, a node, have a file of transactions on your computer, a ledger. 2 government accountants, let's call them miners, have the same file on theirs, so it's distributed. As you make a transaction, your computer sends an email to each accountant to inform them. Each accountant rushes to be the first to check whether you can afford it and be paid their salary, which is bitcoins. The first to check and validate hits reply all, attaching their logic for verifying the transaction, which is the proof of work. If the other accountant agrees, everyone updates their file. This concept is enabled by blockchain technology.